Today we're going to look at actually finding angles. So in the last video, we were giving you an angle and you were finding the ratio of the sides of a right angle triangle. This time we're giving you the sides of a right angle triangle and asking you to find the angle. Now, the notation is So our notation was sine theta is equal to opposite over hypotenuse. Now, this time we have answers for opposite over hypotenuse. So in this case, I'm going to say 1 over 2. We want to find the angle. What we're going to do is I repeat, we are not going to divide both sides by sine. That is impossible. What we're going to do is we're going to take what we call the inverse of each side. That is how we get theta, which is our angle, by itself. So again, we will not divide both sides by sine. We take the inverse, which is the sine to the -1, which is actually a button on your calculator, to find the angle. So again here, look down here, we have cosine A, so we're saying A is our angle, which is equal to the ratio of root 2 over 2. Therefore, to find A by itself, we take the inverse of cosine of each side, which is equivalent to the inverse of cosine, root 2 over 2. That is simply something that you put into your calculator. So I'm going to pull up a calculator to show you. So to find the inverse of cosine, I'm going to do second cosine, and then that question had root 2 over 2. So second square root of 2 divided by 2, which is 45 degrees. So what we're saying is that a 45-degree triangle has a ratio, so cosine 45 degrees is equal to root 2 over 2. Let's look at an actual problem. Find the measure of the angle A, so this is the angle that we're finding, round to the nearest tenth if necessary. So they're actually giving us all three sides, so we can use sine, cosine, or tangent. So let's use sine. Sine theta is equal to opposite over hypotenuse. So if this is my theta, which is my angle A, opposite is going to be my 9, my hypotenuse is going to be 17. So 9 over 17. Now to get theta by itself, I'll take the inverse cosine. So it looks like this. Sine inverse sine, sorry, I said the wrong thing there. 9 over 17. Then I go to my calculator. Second sine of 9 divided by 17. 31.96, which says round, so it'll be 32.0. Next one, find the angle, measure B. So there's B. Now, what you'll notice is if I use sine, I could do sine theta is equal to opposite over hypotenuse, so 14.4 over 17. I could also do cosine theta, which is equal to adjacent over hypotenuse, which would be 9 over 17. Or I could use tan theta, which is opposite over adjacent, 14.4 over 9. So let's see what we get. First I'm going to do sine, so you do not need to do all these, I just want to show you, of 14.4 divided by 17. Oops. 17. 57.9. Now I'm going to do cosine. Cosine of 9 over 17. So 58.0. This one would be rounded to 57.9. Very close. So that 14.4 must be a rounded number. That's why it worked out that way. And 14.4 divided by 9 is 57.9. So as you can see, they're all about 57.9, 58.0. So I would accept either. And again, that's just because that 14.4 must be a rounded number using the Pythagorean identity. A golfer is standing at a tee looking at the green on a hill. The tee is 36 yards lower than the green at an angle of elevation. So angle of elevation means from a horizontal looking up of 12 degrees. From a camera in a blimp, the apparent distance between the golfer and the hole is a horizontal distance. Find the horizontal distance. So it's really saying find x. So I'm going to look at, here's my angle of 12. So I am given, this is my hypotenuse, this is my opposite, and this is my adjacent. Based on what they're giving me, I must use tangent because I don't have any information for hypotenuse. So tangent of 12 degrees is equal to 36 over x. I'm going to cross multiply, so I get x is equal to 36 over tan 12 degrees. Then I go to my calculator. So 36 divided by tan 12. 169.4. The hill of a roller coaster has an angle of descent, meaning that from a horizontal, it's an angle going down. Another word for that is an angle of depression. Has a vertical drop of 195. Find the horizontal distance. Okay, so here we have horizontal, or the hypotenuse. There's my angle. This would be opposite, and this would be adjacent. Now, we don't have anything for the hypotenuse. So again, we're going to use tan. Tan of 60 degrees is equal to opposite 195 over. So x is equal to 195 over tan of 60 degrees. And you can go to your calculator, and it's approximately 112.6.